This is my final project presentation for the Spring 2014 Big Data Analytics course at the Harvard Extension School. My name is Teresa Dong, and I will be presenting the topic of data visualization with D3. This slide goes over the structure of my presentation. I will first give a brief overview of D3 and explain what problems it solves and reviews its strengths and challenges. Then I will follow up with a demonstration of D3 through a visualization I made to illustrate some D3 concepts and techniques. Finally, I will relate this final project to our course by providing a schematic of how D3 can be used to visualize big data and review two libraries based on D3 whose purpose it is to visualize big data. The D3 website gives one of the best descriptions of D3. D3 is a technology based on the web standards of JavaScript, HTML, CSS, and SVG that can be used to create powerful visualizations based on data by modifying the DOM. The acronym D3 stands for Data-Driven Documents, with the documents part of the acronym referring to the DOM or the Document Object Model. The problem D3 solves is that it provides a flexible and powerful visualization tool to explain and explore complex datasets with just your web browser. Two such visualizations are shown on this slide. The visualization on the left explains why Markey won the Massachusetts 2013 state senate election. The visualization on the right uses D3 to explore Obama's 2013 budget by clicking through the different budgets, which will slice the budget into a bunch of different kinds of cuts. Now that we have a basic understanding of D3, we can now briefly go over its strengths and challenges. D3's power comes from its basis on web standards. It can be run on any modern browser with no need to install specific software or plugins. Furthermore, because it uses declarative programming, it can perform much more complex transformations with less code, as seen on the example on this slide. On the other hand, the basis of D3 on web standards also leads to some challenges. Because it is based on web standards, it mostly works with modern browsers, and older browsers may run into issues. Furthermore, because it is based on web standards, you need to learn the technologies of HTML, CSS, JavaScript, and SVG, so there is quite a learning curve. The demo that I will be using for this final project compares download speeds among G8 countries. Using the brushing tool on the bottom, we will be able to interactively adjust the x-axes for all of the area charts using D3. This demo will illustrate the concepts of selections, data binding, loading data, reusable charts, coordinating axes, and SVG objects such as the brushing tool. The visualization itself is based on the multiple area charts with D3.js tutorial by Tyler Craft. To set up this demo, we will first download his source code as the basis for our visualization and make changes to adapt it to our new dataset. Therefore, the first step would be to download his source code from his website and extract it to our local computer. Afterwards, we will download the latest version of D3.js and extract it to a subfolder D3 in the extracted source directory. I decided to use a local copy of D3.js to keep the visualization self-contained. Finally, we will need to download the data that we'll be using for the dataset from Ookla NetIndex, provided by the link in this slide, and extract it to our computer. Afterwards, we will modify this datasheet in Excel to just extract the G8 countries and only extract the metric of download speeds, which we will save in G8_daily_speeds.csv. Though the D3.js files are just HTML files, it is best to use a local server when running D3 code because sometimes you may run into issues when you're loading from external data sources. Therefore, we need to use a local web server. The server that our demo uses is a simple HTTP server included with the Python installation. For Windows users, they probably need to go to python.org to download Python and then add it to their system path. Linux and Mac users already have Python installed. To start the server, you will go to your command prompt and type in the command python-m simple HTTP server. Once this command is entered, you can go to your web browser, specifically to the URL specified on this slide, to see the server loaded. D3 code is simply text code, so it can be edited with any text editor. I personally prefer Sublime Text 3 for its syntax highlighting and autocomplete features. Now we will go over some basic concepts of D3. The first concept that we will go over is the DOM structure. As mentioned before, D3 is based on multiple web technologies, which when combined allow data to dynamically drive the DOM. The base of the DOM is parsed HTML and CSS code. HTML contributes to the DOM by providing the structure, aka the elements or tags, as the building blocks. In the code on this slide, you can see the HTML tags between brackets. CSS, on the other hand, is used mostly for visual presentation. Its concept of selectors is essential to D3 to select elements for transformations to be applied. We will go more into selectors later. Finally, the last aspect of D3 is JavaScript. JavaScript tells the browser to make changes to the pages after it's loading and is what provides interactivity to the DOM. Using JavaScript, we can remove elements, add transitions, and provide interactive effects such as brushing and tooltips. JavaScript is also what we use to bind data to the DOM. This allows us to read in external files and then add and remove elements dynamically depending on the input. On the slide here, you can see the HTML elements as in the brackets here. The CSS code itself is hidden, but CSS can be attached to the DOM through the style tags. JavaScript, on the other hand, is attached to the DOM through the script tags. The script tag in the header here is linking to an external JavaScript file. On the other hand, D3 code will be written in the script tags down here. Because our dataset is in the CSV format, we will use the helper method d3.csv to load in the DOM. D3 has many helper methods for dealing with multiple file formats. Once the data is loaded into the DOM, we can call the callback function to process the loaded data. Here, our dataset is g8_daily_speeds.csv, and our callback method is createChart. The code for createChart is shown below. You would want the callback method because you would want to process data after you have it loaded in the DOM. For my code, I made some changes to the original source code because the original source code was based on annual data, while my data is based on daily data. So I needed to add some source code to process the days separately from the numeric values, aka the download speeds, and then also to process the date from a string that we're having inputted to an actual date object, which will be used in the x-axis. On this slide, we illustrate the importance of the callback function in processing data. On the left, we just have the straight demo2.html, where we updated the helper function d3.csv to reflect the new dataset, but without updating the callback method. Here we can see that no data loads because the code is looking for a year column, but there is only a day column in the dataset. Also, no axes are loading because the code is not processing the date column correctly, so there are no date objects. On the right-hand side, we have demo3.html where we updated the callback function to process the day variables correctly. In addition, we also replaced any references to the year with the day. As you can see, there is now a valid x-axis and y-axis due to the callback method calculating the maximum data point for the y-axis and creating the date object for the x-axis correctly. The next slide illustrates the D3 concepts of selections. Using selections, we can now resize the visualization. Before resizing, we can see that the charts are all cramped together with the brushing tool running into the bottommost chart. Therefore, you want to resize the canvas size to move the brushing tool down and to stretch the charts out. Before, we had a height of 500 for 5 charts. Now that we have about 8 charts, we probably want a height of about 800. So we can do this by selecting the SVG object with the pen tag and then modifying the height of this object using the attribute selection operator method. This next slide illustrates data binding. We bound the data to the DOM using the data function as shown in this code. Because the area chart was already created in this .area, we are using the update method to bind the data to the area chart. Because the data join method update was used, there is no need to specify it because it is the default method. Other data join methods are enter, which joins data elements that don't yet exist, and exit, which removes any remaining unbound elements. The next concept we will cover are reusable chart objects. Note that we have 8 very similar area charts for our visualization. Due to the similarities and properties, there is much value in creating a chart object that can be reused. To do this, we create a chart object which takes an array of properties. Many of these properties, such as width, height, math data point, and margin, are constant across all the charts, while the variable properties of data, ID, name, and show bottom axis come from the input data but are calculated using similar methodologies. The chart object is then used when processing the input data. For each country inputted, we create an instance of the chart object with the arguments being passed in from the data. If you remember from the previous slide, the name property helped distinguish one chart from another. We will now use CSS to color in the area charts accordingly. The CSS selector used here is a parent-child containment, which means for each tag G of the class specified by the country name, we set the fill of its child path with the color specified in the RGB rule. So here the parent is G with the class country name, and the child is path with the class chart. and then here is where we specify what color the chart should be. On the next slide, you see the output from restyling the charts. In this chart, we recolored the old charts of France, Germany, Japan, and the USA with our new colors to make it more contrasting, and added classes for the new charts of Canada, Italy, and Russia so that they are now colored in. The next concept we'll cover are SVG objects. SVG objects are what gives the visualization its interactivity. SVG stands for Scalable Vector Graphics and is a text-based image format that is syntactically similar to HTML. This makes it ideal for D3 manipulation. The first D3 object that we will review is the D3 area chart object. The area object is defined as a closed polygon where x is the width, and the top line is y1 and the bottom line is y0. We see that the x range is similar for both the context area and the area chart. Therefore, we will use the same time x scale for both. In our code, x is just the time scale. Y0 is the height of visualization. Y1 is what really defines the area chart, as it is the top line of the polygon and determines how much of the area is colored in. For the context area, it is just 0 as there is no area. But for the area chart, we want Y1 to be the actual data values. Also to note is the interpolate method. D3 area methods take in data as a series of data points and fills them in depending on the interpolate method specified. On this next slide, we will go over the SVG axis component. SVG axis components provide a quick and easy way to draw axes in D3. The orient method specifies the orientation of the tick labels and marks relative to the axis. The number of tick marks for the y-axis was manually specified here with the ticks method. Generally, however, the number of tick marks can be specified by taking in a scale object, which is what happened in the case of the x-axis. The final D3 concept that we will cover is brushing. The brushing object is what gives a visualization its interactivity. Using the brush, we can pan and zoom on different time periods. The brush was created with the d3.svg.brush function, with the x range determined by the x function. The on function calls the onBrush method. This onBrush method automatically determines the range of the x-axes for all charts based on user input. This method will return a d3.brushExtents object, which specifies the x range. Finally, the brush object is called by the call function to redraw the brush depending on the user input. In the presentation, we saw how D3 can visualize a moderately sized dataset. Connecting this to the topics that we learned in class, I now present a flowchart of how we could possibly use D3 to visualize big data. Because D3 binds objects to the DOM, it is probably not a good idea to bind all the data to the DOM at once. Instead, D3 should only bind the relevant subsets or summaries of the data at any one time. Afterwards, the visualization can be updated in real time using the enter, exit, and update join methods whenever a new query or analysis is run. This incremental approach to visualization is the theory behind two JavaScript libraries based on D3 that are optimized for big data. Crossfilter.js explores multivariate datasets in the browser and supports fast interactions and coordinated views. We can think of it as an extension to our demo, but to be used with much larger datasets. Similarly, Cubism.js specializes in visualizing time series data and can be used to visualize real-time updates to time series. Both are based on the idea of incremental adjustments, as the base visualization stays pretty much the same, but changes such as filtering or adding new data are made incrementally to give the data its interactivity. Now we will just go over the final visualization in the browser. So opening up the browser, we have our visualization here, and then using the tool on the bottom, we can either expand the time period to show the entirety of the data, contract the brush tool to just show a smaller subset of the time period, say like 2 years, pan the tool from left and right to see the same interval to say 2 years, but for different date ranges. So here we can look at 2011 to 2013 versus say 2009 to 2011. So this is the tool that we created in our demo with d3.js.